hackers pray for bugs like this, okay? And I'm literally not kidding. Like this is the kind of bug where if you're someone who has any experience with writing like exploits or malware for Windows, you're like, oh my god, that's perfect. Just leave it there. Trend Micro Apex Central RCE Floss scores 9.8 CVSS on in-prem Windows versions. We'll go into the bug here in a second, guys. I do want to highlight, I tried so hard to learn what Apex Central even is, okay? And I went to trendmicro.com and I went to the product page. If you go to products and services and you click on Apex Central, this is where it goes. Guys, I don't know what you're doing in the marketing department, but dude, I gained nothing from this. So what I had to do is go to ChatGPT and ask it what Trend Micro Apex Central is, and I got this. Apex Central is Trend Micro's web-based centralized management console for administering and monitoring multiple security products from a single place. Okay, so that's terrifying. This is the, I guess, on-prem solution for if you have other Trend Micro products in your network, you use this to manage them. So as a result, an RCE in this platform is not super great. Now, the bug was found by Tenable, another security company that does a bunch of research all the time, and they did a very nice write-up where they have not only the bug itself, but they have all the structures in kind of a pseudo C language, all of the opcodes and the associated names. It's beautiful. So let's go into it. And as you're going through here, you will notice that this article is very short. This whole thing contains 3 bugs. So not too complicated. Message receiver.exe listens on default TCP port 20001 and accept messages that have the following structures. Okay, so when I read this, I was like, oh, surely then it means that there is a vulnerability in the parsing. Oh, maybe the header of the packet has a length field and either they don't validate the length or there's like an integer overflow in the packet. Okay, so let's see what's going on here. Ransomware. It's out there, it's coming for you, and if it gets in, it's gonna do damage to your network, guys. That's why I trust ThreatLocker to prevent ransomware and contain 0 days. The cool part about ThreatLocker is that it understands that hackers are eventually going to get in. The question is, what do you let them do once they get in? Zero trust principles tell us to deny by default and to allow by exception. And using ThreatLocker's platform, you can do just that. Guys, here's the reality of the situation, okay? Mark from HR opened an email and he downloaded probably shouldn't run this .ps1, and I got bad news for you. He's gonna run it. Now, what's cool is that when he actually does run this, inevitably, ThreatLocker is gonna pick it up. Now, luckily, when we ran this, ThreatLocker picked it up, because if you go into this and you open a PowerShell, you will see that it does something we probably don't want it to do, okay? Guys, the reason that I like ThreatLocker is because of its learning mode. It's not realistic when you use Zero Trust to have to manually put in every policy that tells the Zero Trust platform what every application is or is not allowed to do. Learning mode gives you a set window where you can define how long ThreatLocker is going to learn for. It then creates an allow list based on that learning session. Using all of this, you get a clean Zero Trust platform that allows you to make sure that your network isn't doing weird stuff like probably shouldn't run this .ps1. Guys, the best way to help the channel out is to go interact with the sponsors, go check out ThreatLocker yourself, and next time Zero Trust comes up at your company, give ThreatLocker a shot. ThreatLocker, thank you for sponsoring this video. Back to the video. So we have the header here, we have a big endian message size, some reserved field, we're not sure what it does. We have the body of the message that tells us, what type of message is this, and then the actual data, okay? Now we'll go into this a little bit lower and you'll see that literally the entire bug is right here. There is an opcode that allows us to send the process a request to load a DLL with an altered search path. That is the whole bug. Now, when I read this, I was like, wait, that can't be that bad, right? Locally, what that means is you're trying to maybe enable a driver or enable some kind of DLL that's already on the system. Who cares? But then I remembered, this is a Windows tool. This is a Windows platform. And so what this means, guys, is you are able to specify an SMB share, right? Because load library exa is being called, it's going to use the path as a Windows file system path, which means by default, you can specify an SMB share. So this thing can literally go out and reach across the internet over SMB3 and go and pull down your evil.dll from a repo and then just load it onto the system. Now, the reason why I said this is a bug that hackers pray for is that if you've ever done OSCP or OSEE, right, those courses typically have some section where you need to write shellcode that parses the process environment block or thread environment block to look for like load library A. You have to write a bunch of shell code to do really complicated stuff to look for this function, to then load and inject a DLL into a remote process. Like, it's very complicated, and they're not getting caught by EDR too. We're getting caught by antivirus. It's like really complicated. But in this process, it literally has preloaded for you, ready to call, just load library exa, and you can use this path to load the DLL. That's fucking crazy. And so yeah, what you can do is not only SMB, like you can set up Samba, which is the Linux host for SMB. You can use that to host your evil DLL and then just shoot that message at the Trend Micro server, and then bada bing, bada boom, it picks up the DLL and loads into the process and just like loads it there. And again, remember, this is existing in the not only the security context of System, which I had to read this twice when I saw it. If you're not aware, guys, System is like God mode on Windows. There's like trusted installer now, right? But like for a long time, System was like the guy. And yeah, so you can use this to now not only be System on that machine, but you have access to the rest of the network where they have other Trend Micro products installed. So like not super great, right? I do want to highlight too, there are like 2 other pretty big bugs. Again, they're not like full RCE, right? But it's only a 3.1. Sorry, I'm a dumbass. It's not a 3.1. This is a CVS scoring system version. It's a 7.5. But basically, right, because it's a protocol written in C, right, you have an issue where you could potentially have return values that are null, which will cause somewhere else in the code to dereference a null pointer. This happens not only here, but in another place in the code, right? And so you have a couple places here where the code could be crashed, by a malicious attacker. And this being a security product, if someone is malicious in the network, and they want to do something evil over here, but the evil thing is being watched by this like Apex Central thing, well, you could just shoot this packet at the computer that runs Apex Central, you'll crash Apex Central, and then go do your evil thing, right? So this is like when you have a DOS scenario in an antivirus product, it's like not the best place to be, right? Now you may be asking, this one's actually has a bit of a weird edge to it, right? Would Rust have fixed this? Well, okay, so first of all, for the load library exec A function, no, Rust would not have fixed this, right? This is not a Rust or a memory safety issue. This is more of a system design. We forgot about this one edge case in load library A issue, right? Now, I'm assuming that these networks, by the way, have like firewall rules set up where if they see SMB requests shooting out the network, they're like, wait a minute, a VPN should be carrying that request to like maybe another client's computer, right? So maybe that interface is not being blocked, like the tunnel interface, but the regular, just like the WAN interface catching outbound SMB requests, maybe we block those, okay? And probably inbound ones too. So yeah, Rust would not have fixed this, guys, but I do want to highlight that. So technically, from a null pointer dereference standpoint, right? The raw, a null pointer is being dereferenced. Yes, Rust does fix this. However, the ability for a function to return null sort of does exist in Rust, right? We've seen this literally, and I think it was either the Google Cloud crash or the Cloudflare crash. Again, we've had multiple like cloud failures in the last couple of weeks or months. Those were because of one of them, a unwrap function, right? In Rust, we have these 2 types. One is an option, right? And one is a result. The option is the more important one here because an option is basically a generic enum of something or none, right? And so when you get the option returned from a function, you have to unwrap it, right? You have to you don't have to unwrap it. You have to remove the option layer from the thing to reveal what is inside, right? Problem is, if a function returns an option, which can be none, if it returns none and you unwrap none, this will panic the process, right? This will kill the process in the same way that a null pointer dereference kills that process, right? So it's like, people say like, oh, null pointer dereferences don't exist in Rust. Like, okay, sure, they like technically don't because like pointer dereferences don't exist in Rust, but the idea of a nothing is like, it still is in the language, right? So you can return a nothing from some function and then, unwrap it and kill the process. Now, obviously, what you should not be doing ever is using unwrap. You should be using a match statement to see, is the thing something or is the thing none, and then taking some appropriate action based on that. But this video is not a Rust lesson. If you want to learn Rust, by the way, go check out Low Level Academy. I'll show you real quick. I mean, check it out. We got all these courses here. You got Foundations of Rust. Great course, by the way, getting a lot of reviews. We also redid some of the courses here. You can run the code in the browser. And guys, also, it's on sale. Go check out the sale while it still lasts. Anyway, if you like these videos, guys, thank you so much. hit that like button, hit subscribe, and then go check out this other video you will like just as much. My hair is very long. Say I have nice hair. We'll see you next time. Goodbye.